Today we are going to discuss electrophilic addition to alkene. First of all, try to understand what is electrophile. Electrophile is electron-loving species. It can be electron deficient or positively charged species. Now come to alkene. Alkene is a hydrocarbon that contains carbon-carbon double bond. So if we take the example of ethene molecule. In ethene molecule, each carbon has formed 3 sigma bonds. Due to the formation of 3 sigma bond, each carbon is sp2 hybridized and the geometry will be triangular planar geometry. And you know, pi bond is formed by unhybridized orbitals by the sidewise overlapping. And due to presence of pi electron, alkene is electron-rich molecule, and that's why electrophile get attracted towards alkene. So let's take an example of ethene molecule. Here one bond is sigma bond and another bond is pi bond. So if I represent pi bond with 2 electrons, it would be easier for you to understand the further mechanism. When electrophile approaches, either of the carbon can utilize both the pi electrons to make bond with electrophile. As electrophile is devoid of electron, it doesn't have any electron to make bond with the carbon. If I number it as carbon 1 and this is carbon 2. So for example, carbon 2 utilizes both the pi electrons to make bond with electrophile. So here carbon 2 has formed bond with electrophile and carbon 1 left with no electron. So positive charge will develop at carbon 1. Now come to the another possibility. When carbon 1 utilizes both the electrons to make bond with electrophile. So here carbon 1 has formed bond with electrophile and now carbon 2 left with no electron. So now positive charge will develop at carbon 2. So that's how carbocations are formed. Now in the next step, nucleophile will get attached to formed carbocation and you will get your product. In the same way, nucleophile get attached to formed carbocation and result in the product. So this is the mechanism of electrophilic addition to alkene molecule. First of all, you need to identify electrophile and nucleophile in the given reagent. For example, HCl. In HCl, H plus is the electrophile and Cl minus is the nucleophile. In HBr, H plus is the electrophile and Br negative is nucleophile. In HCN, H plus is the electrophile and Cn negative is nucleophile. In water, H plus is the electrophile and OH negative is the nucleophile. If we take the example of ROH is alcohol. So in alcohol, H plus will be the electrophile and RO negative alkoxide ion will be the nucleophile. Now ROR, this is ether molecule. In ether, R plus will be the electrophile and RO negative alkoxide ion will be the nucleophile. Here we are going to study electrophilic addition to symmetrical alkene. And ethene is the example of symmetrical alkene. When ethene react with HCl, first of all identify the electrophile and nucleophile in HCl molecule. Here H plus will be the electrophile and Cl negative will be the nucleophile. If I number this as carbon 1 and this is as carbon 2. Either of the carbon can utilize both pi electron to make bond with the electrophile. For example, if carbon 2 utilizes both the electrons and form bond with H plus ion, carbon 1 will develop positive charge as it left with no electrons. Now in the second condition, when carbon 1 utilizes both the pi electrons and make bond with H plus, carbon 2 will left with no electron. It will develop positive charge. Now we have nucleophile Cl negative ion. It will get attached to the formed carbocation and result chloroethane. In the same way, in the second carbocation also, Cl negative will get attached to the formed carbocation and result in the formation of chloroethane. Now try to understand what will happen if we do electrophilic addition to asymmetric alkene. Propane is the example of asymmetric alkene. Here again I am going to represent pi bond with the pi electrons. Now we are going to react propane with HCl. So first of all you have to identify electrophile and nucleophile in the given reagent. Here H plus is the electrophile and Cl negative is the nucleophile. Either of the carbon can utilize both the pi electron to make bond with the electrophile, that is H plus ion. Now I am going to number this molecule 1, 2 and 3. If carbon 1 utilizes both the electron to make bond with electrophile, carbon 2 will develop positive charge as it left with no electrons. This formed carbocation is secondary carbocation as it is bonded to two other carbons. Now in the second condition, when carbon 2 utilizes both the pi electrons and make bond with H plus, that is electrophile. Now carbon 1 left with no electron, so it will develop positive charge. And the formed carbocation is primary carbocation as it is bonded to just one carbon. We have already studied the stability order of carbocation. Tertiary carbocation is the most stable carbocation than secondary, and primary carbocation is the least stable one. In secondary carbocation, there are more plus I effect, and because of hyperconjugation, it is more stable as compared to primary carbocation. Now nucleophile get attached to the formed carbocation, that is Cl negative. Result the formation of 2-chloropropane. Cl negative will get attached to the primary carbocation as well, and it will result in the formation of 1-chloropropane. As we just have discussed, secondary carbocation is stable carbocation, and stable carbocation formed faster and they formed in greater proportion. As secondary carbocation is a stable one, it will form in greater proportion, so it will result in the formation of major product that will form in the major quantity. That's why it is called as major product. While primary carbocation is unstable one, so it will form in lesser proportion and leads to the formation of minor product that will form in lesser quantity. Now come to the another example of electrophilic addition to unsymmetric alkene. Propane is the example of unsymmetric alkene. Here again I am going to represent pi bond with the 2 electrons. When we are going to add water molecule to it, it will require some catalyst, but I am going to skip that part of the reaction. First of all, identify the electrophile and nucleophile in the given reagent. Here H plus will be the electrophile and OH negative will be the nucleophile. Now number this molecule. So I will number it 1, 2 and 3. Now either of the carbon can utilize both the pi electron to make bond with the electrophile. If carbon 1 utilizes both the pi electron to make bond with electrophile H plus ion, carbon 2 will left with no electron, so it will develop positive charge, and this formed carbocation is secondary carbocation. Now carbon 2 utilizes both the pi electron to make bond with electrophile H plus ion. Here carbon 1 will left with no electron, so it will develop positive charge, and as a result of it, primary carbocation is formed. No, secondary carbocation is stable than the primary carbocation. Now nucleophile will get attached to the formed carbocation, and as a result of it, 2-propanol will formed. And when nucleophile will get attached to primary carbocation, 1-propanol will formed. And we just have discussed stable carbocation formed in major proportion. So that's why secondary carbocation will lead to the major product. So 2-propanol will be the major product and 1-propanol will be the minor product of this reaction. So let's compare the product of electrophilic addition to asymmetric alkene. As we have taken the example of propane and we have added water molecule to it, we have got 2-propanol as the major product and 1-propanol as the minor product. And when we have added HCl molecule to the propane, we have got 2-chloropropane as the major product and 1-chloropropane as the minor product. Here when you observe, negative part or the nucleophile get attached to the sp2 hybridized carbon that is bonded to less number of hydrogen. In the first reaction, nucleophile is OH negative ion and it gets attached to the sp2 hybridized carbon that is bonded to less number of hydrogen. So this carbon is bonded to just one hydrogen while the another carbon is bonded to two hydrogen. So that's why OH get attached to the carbon that is bonded to less number of hydrogen. That's why we have got 2-propanol as the major product. In the same way, in the second reaction, nucleophile is the Cl negative ion and it get attached to the carbon that is bonded to less number of hydrogen. So that's why we have got 2-chloropropane as the major product. This rule is named as Markovnikov rule. So let's apply this Markovnikov rule in another example. Here I have taken the example of unsymmetric alkene, that is 2-methyl propane. Here you have to add HBr. First of all, identify the electrophile and nucleophile in the given reagent. Here H plus is the electrophile and Br negative is the nucleophile. And as per the Markovnikov rule, nucleophile get attached to the sp2 hybridized carbon that is bonded to less number of hydrogen. So now compare both sp2 hybridized carbon. This sp2 hybridized carbon is bonded to no hydrogen. That means it is bonded to less number of hydrogen as compared to this. So that's why negative part will get attached to this carbon. And you will get 2-bromo 2-methyl propane as the major product, while you will get 1-bromo 2-methyl propane as a minor product.